Hello friends, this is example 10 on filter module, and the question is identify the type of the filter of the given circuit. And here the circuit is shown. See here, one input voltage source is here connected. With it one series inductance L is connected, and another capacitor is connected in series, and one resistor is there which is also connected in series. This is series RLC circuit, and we are taking the output voltage across the resistor. We have to determine what type of filter is this one. Okay, so as I mentioned in my previous videos, first what we have to do, we have to transform this circuit into frequency domain. Okay, so the resistor remains the R only. Okay, and see the L is converted into j omega L, and see the capacitor is converted into 1 by j omega C. The input voltage Vi of t is converted into Vi of j omega, and the output voltage V output of t is converted into V output of j omega. Okay, now we have to calculate the transfer function for this circuit. See, simply by voltage division rule we can get V output of j omega by V input of j omega, that is transfer function of this circuit, and we get H of omega is equal to V output of j omega by V input of j omega is equal to R by R plus j omega L plus 1 by j omega C, and by simplifying you will get equal to j omega RC by j omega RC plus j square omega square LC plus 1. Okay, this is the transfer function for this circuit. Okay, now what we have to do to determine what type of filter is this one, we have to put omega equal to 0 and omega equal to infinite, and we have to check what is the value of the transfer function. Okay, so see here we got the transfer function as this one, that is H of omega equal to j omega RC by j omega RC plus j square omega square LC plus 1. So H of 0, by putting omega equal to 0 we will get 0 by 0 plus 1, that is equal to 0. So H of 0 is 0, and see H of infinite, by putting omega equal to infinite you will get j infinite RC by j infinite RC plus j square infinite square LC plus 1. So that will result in infinite by infinite term. So this is not defined in mathematics, so that what we will apply, we will apply L'Hospital rule. So H of infinite equal to limit omega tends to infinite j omega RC by j omega RC plus j square omega square LC plus 1. Now by taking differentiation in the upper and lower hand side, upper and lower side, we will get is equal to limit omega tends to infinite jRC by jRC plus j square 2 omega LC. Now see, by substituting omega equal to infinite in the lower as infinite term will be there, so we will get H of infinite as 0. So what we are getting from these two, we are getting H of 0 is equal to 0 and H of infinite also equal to 0. So this is the what criteria? This is the criteria for band pass filter. Okay, so this circuit is nothing but one band pass filter. Okay, this process you all know for analyzing the circuit. This type of numericals are very important for filter module. This is all for this video. In my next video I will show you some more problems. Thank you for watching.